don't say anything about method. Therefore, my answer to the question is that geology uses the same method as all the other sciences. In this respect, it's equal to all the other sciences. If there's anything peculiar about geology, is that it mainly deals with inverse problem. That's because it is an historical science. The way of defining a possible solution for an inverse problem is well explained by the quote of Sherlock Holmes, showed in this slide. He defines this as reasoning backward. That's very similar to abduction from peers. There's no surprise, because we think that the work of a geologist is very similar to the one of a detective. That's a very prolific analogy that we will come back in this presentation. But still, we are still talking about the origin of new ideas. Also, Sherlock Holmes needed to test his ideas, looking for proofs after the reasoning backward. To summarize, we can say that the hypotheses of historical natural science are typically concerned with long past, singular events and processes. Historical science is an inverse problem, and we can use the analogy with seismic inversion to better explain the point. So we have a result that in seismic inversion is the actual seismic data. We assume a rule that is in seismic inversion the convolution model, and then we define a set of initial conditions, so parameters, and through deduction we derive a synthetic result. In this case, a synthetic seismic, in case of the seismic inversion. The initial condition, together with the assumed rule or rules, constitute a model, a hypothesis that has to be tested against data. And in seismic inversion, what we do is to compare the synthetic seismic with the actual seismic. Unfortunately, all the inversion algorithms suffer of non-uniqueness problem. In other words, there is more than one geological model consistent with the data. As suggested by Trantola in 2006, in theory we need to produce all the possible models and to test them. This is of course almost impossible. It is possible instead to use the multiple hypothesis method suggested by Chamberlain more than 1 century ago. Our job as geologists is to find key data to discriminate between the possible models. In order to do that, it is important to try to reconstruct the initial conditions, if remnants or traces are available in the geological record. This is the first page of the reprint of the famous paper from Chamberlain. The American geologist, without mentioning the inverse problem, was clearly aware of the non-uniqueness problem. Let's talk about observation and theory now, because in my view this is a critical point, not really well understood. There is a dangerous confusion about it, and I will try to clarify it. This dilemma was also a major source of puzzlement and confusion when I left the famous outcrop where Professor Muti brought me. So the point is about who came first, theory or observation. I know it is a bit of a chicken and egg question, but I hope I can make my point with few slides. Talking about observation, I have a challenge for you people out there. What do you see in this picture? I bet I know what you're thinking about right now. Well, it happens then that according to some studies, children see something different. They see 9 dolphins. You are able to see them too, aren't you? This is only a joke, but it's an example to introduce my point. We all see only what we already know. There is no such thing like pure observation. And I will develop this point in the next 2 slides, but just think about it. You were able to see the 9 dolphins as soon as I told you there were 9 dolphins. So my answer to the chicken and egg dilemma is, according with Popper, theory comes first. All observation is selective and theory-laden. There is no pure observation. A few years ago, a paper created agitation among geoscientists. This paper was about an experiment in which different seismic interpreters were asked to interpret a synthetic seismic profile. The result of the experiment was astonishing for someone. Different people, different interpretation. No surprise for me. The result of this experiment is supporting my claim that theory comes before observation. The different interpretations were, in fact, due to the different experiences and backgrounds of the seismic interpreters. Any one of them applied his own model to the data. So, for example, an interpreter with experience only in soil tectonic will use a model with salt in it. It is important to remind that all the interpretations in this example were right, in a way, based on the available data, the only one seismic line. The different interpretation could equally explain the data. And that's in fact because interpretation is just a special kind of inverse problem.